Yes, with the comments, everything. I will check this weekend and then I will increase your marks.
The previous one is.
Yes, previous one. I said 2 marks I will increase. Hi, Zainab.
Hi, Miss. Good afternoon. How are you?
I'm fine. This camera is there. That today some students will join at least, because last time there were only maybe 7, 8 students. So next lab will be the last lab. 7, yes, it is there already.
Yeah, so.
So next lab will be the last lab and then final exam. Okay.
After 2 weeks.
After 2 weeks. Okay.
No revision.
You want revision or not?
Do we have?
What you want?
Yeah, right.
It's better that if we finish it early.
Yes. But do
Do
we
you need-
revision?
I don't know. You tell me.
So what revision?
What you will do? The labs are the same, almost the same.
How many labs?
And what I will do is I will make a folder. You don't have to like memorize commands. I will make folder in these computers and I will put all the labs there. And then I will give you the question. You can see the labs and then from your own understanding, you can use those labs. Okay. You don't have to memorize the labs. Yes, you will have all the codes.
And the question.
I will write something because I work with MLX file. I will write, okay, this lab is lab 1, lab 2, lab 3. You should remember that what is happening in the lab. I will not write the questions, I think. Okay, good. You don't have to memorize. Just remember that this is which lab, this is which lab. That's it. Okay.
The exam will be on one lab?
Here,
I don't know.
during your class.
The exam will be only solving one question or one lab?
Maybe
Or
2
mixed?
questions. Maybe 2 questions.
2 questions.
Not one lab. Something mixed, something new.
New.
From like question will be new from the lab.
Like question in lab 1 and lab 5. Like this?
No, no. Question will be different. Like I can
You would not pay anymore.
maybe 2. 1 hour. You have 30 minutes for one question, 30 minutes for the other. You will have everything here. Everything. There will be no internet, but no internet. Okay. Let me open.
What do you mean there's no internet?
On the exam day, there will be no internet.
No.
Yes, you don't need internet. I will put all the data there.
Apa ni kau tak apa?
Okay, one overview about the previous lab, what we were doing in amplitude modulation before. In the previous lab, we did frequency modulation.
Yes.
And what we were doing in the previous lab when we were doing amplitude modulation, double sideband, suppressed carrier, and transmitted carrier, what we were doing? We had some signal,
Yes.
yes, and then we were having a carrier, we were multiplying them,
Yes.
then transmitting. Yeah, message. One message signal and one carrier, and then we were transmitting, multiplying them, and that's it. So today we have quadrature amplitude modulation. So what does it mean? It means that we will have two carriers, one carrier like this, and then another carrier 90 degrees shifted. Sorry, this should be. If we shift the sine wave 90 degrees, what we get?
Miss,
Yes.
Aha.
Miss,
Yes.
could you share screen, please?
Okay, sorry.
Okay.
Sorry, I forgot. And then also I should share this camera. Okay, so this is the quadrature amplitude modulation. Here we have two type of carriers, two different carriers. One is sine wave and other is 90 degrees shifted. If we shift sine wave, then what we get? 90 degrees. Cosine is starting from 90. This starts from 90. This is cosine. Okay, so it means if we have two carriers, we will have two message signals.
Minus 80. This one minus 80.
Minus 80. Why?
Sorry, 90. Minus 90.
No.
To be cosine.
Yeah, no, from cosine. If from sine we
From sine to
yes
cosine.
exactly we minus 90
that's what I
degrees.
said.
So cosine wave is starting from
Yeah.
90 degrees. This is 90 degrees shift. Okay. So 90 degree shifted version of sine wave is cosine. So what happens in quadrature amplitude modulation? We will have two carriers 90 degrees shifted, and then at the end we will get amplitude modulation as well as phase modulation. Means that amplitude will also be different. You see that here the amplitude of this wave is this. This is sine wave. So this amplitude will be varied, and also there will be a shift in phase. At the output signal we will see it. Okay. So mainly quadrature amplitude modulation is used in digital communication, and we are sending bits of data, for example ones and zeros, in the form of ones and zeros. Then there is a converter which convert digital to analog signals, and then here our work will start. So this you will study in digital communication. In here our communication system, we will only consider analog communication. Okay, so I have my x1 signal, x2 signal, this is my message. So I multiply one signal with cosine, other signal with sine, and then I will sum those up, and then I will transmit. Okay. One more thing about quadrature amplitude modulation is that this is very much prone to noise, because there amplitude is involved. Whenever there is amplitude involved, then noise will be more. Okay, when we will transmit it, we will add noise also. So where it is used mostly nowadays in our mobile signals everywhere, quadrature amplitude modulation is used, because it can, the speed is very high. Okay.
For the analog, speed would be
First, it is digital data, then it is converted to analog.
to be Wi-Fi is high.
Yes, high speed, because packets of data is sent and then it is converted. So this is my quadrature amplitude modulator. What is this? Message.
Signal.
Message. Then this is carrier multiplied with first message multiplied with first carrier, second multiplied with 90 degrees shifted carrier. See here, this is multiplied by cosine, this is multiplied by sine. Then here I will add both of them. M1 multiplied by CT, C1t plus M2 multiplied by C2 of t. This is equals to x of t. Okay. So then at the demodulator, I will get my signal. So for example, after here, this is my channel.
It's equal y of t.
Yes. After passing through the channel, it becomes y of t.
Should be equal. Equal
No,
y of
no,
t.
no, not equal. Here noise will be added.
Noise, yes. Noise is different.
Yeah,
It
noise
should be same, but the noise.
will make it different because before we were making it y of t equals to x of t. Why? Because there was no noise. But to, here in this quadrature amplitude modulation, we have noise. So y of t is not equal to x of t. Okay. So then this x of t is passed through channel, we got y of t. Then y of t is again multiplied with sine of this 90 degrees shifted carrier and then carrier to sine. Then it is passed through low pass filter and then I get my two signals. Estimated message 1 signal, estimated message 2 signal. Okay. Same steps. Okay. Same steps. So this is a step. Okay. So same step transmitter.
Of two signal.
Two signal. What will happen? Transmitter multiplication of signals and then addition. Then channel. Here we will add noise. Then at the receiver, what will happen? We will multiply, yes, demodulate, again multiply with carrier, and then low pass filtering, and then estimated signal. Same steps. You just have to remember the diagram. Okay. So this is my transmitter. First, I will generate message M1. How I will generate message signal? Simply, M1 is equals to, you know that, amplitude with cosine of omega t. So we need amplitude, we need omega naught is equals to 2 pi, f naught we need frequency, and then we need time scale. We were defining 0 to, I think, 1 divided by fs, and then something cycles divided by ff. This was my time
I
scale.
need the phase if I want to add
Which
to
is-
signal.
Yes, we will add them. Which
Okay, I
phase?
didn't need the phase for signal.
Yes, I need this one, this phase. Which phase? Here?
Talk about the phase inside the sign.
Yeah, no. We don't need. If we just write sine, it means it is shifted version. Because there is a phase
No need
difference
to
of
convert up to cosine.
no. There is a phase difference of 90 degrees between sine and cosine. If I write sine signal, it means it is shifted version of cosine 90 degrees. So then I will generate my message, then modulate the message. How I will modulate the message? Just multiply with the carrier. Okay. Modulation of message means message multiplied by carrier. So this is my quadrature amplitude. Okay. So here today we will add noise. So this I will tell you, there is one command for addition of noise in MATLAB. Just remember this one. So we will write this command, data noise or noise, anything you can name it, is equals to AWGN, means additive white Gaussian noise. Okay, and then here, what is data mod? This is my signal x of t, which is the addition of two message signals with two carriers. Okay, then this is my signal to noise ratio. How much is the percentage of noise? How much is the percentage of signal? Then this will measure my power of the signal before addition of noise.
Can you provide for S and R?
So this is the ratio signal to noise. Percentage of this will give some percentage, like how much is my actual signal, how much is the noise. Okay. Then this is noise. Just this command, nothing, not very difficult things. So this is input data, my actual signal x of t. Then SNR, I will give you this number, 20%, 30%, I will give you this. Then this will measure my power before addition of the noise. Okay, we will always write measured here. Okay, and then this we have to define. Like frequency, we define frequency is equal to 10 kilohertz. Like amplitude is equal to 1. Similarly, we will define SNR is equal to 10, 20, whatever I will give you. Then I am done until this part. Okay. What I did is I said I created my message signal, carrier signal, and then I passed it through the channel, and also I added noise. So this was before receiver transmitting. At the transmitter, this happened. Now at the receiver, what will happen? At the receiver, now I got my signal y of t with noise. Okay, then but I will demodulate it. I will multiply it again with the carrier and with the with two carriers. Then I will pass it through the low pass filter, and then at the end I will get my estimated message signals. Okay. These were the steps which we were doing before. Only here difference is we have two signals, and then we are adding noise. Okay. Clear? Any question? No?
No.
Okay. Zainab, is it clear?
Yes, Miss, clear.
So let's write this. Okay. So now use MATLAB to generate quadrature amplitude modulation system to send two messages through channel. So means M1 and M2. Let's write it today without seeing the code. Okay. So show the following. The generated message signals at the transmitter before modulation. But it will be,
Signal.
yeah, which signals?
M1
Message.
and M2.
Yes, M1 and M2. Then carrier at the transmitter. Then transmitted signal. Then receive signal with added noise. And then estimated signal. Okay. So this is my information for writing my signals. Sampling frequency is equal to 8 kilohertz, right? Fs is equal to how much? 8 kilohertz. Let's write the data so that you practice about your exam also. Let's write the data. So first message frequency. FM1, how much? 10 hertz.
10.
Let's write. Start. Yes. So that when you have the data, you should know that what should I do with the data? How should I write it? Same like this, write in MATLAB and then make this a semicolon. Either clear?
Yes.
So example.
Mhm.
So example.
Yes, this one. Okay. What else done? Okay, what is the next thing? Amplitude is equal to 1. This AM1 is equal to 1.
Again.
Message, because it's talking about the first message. So it's better that I write M1 as first message, M2 as second message. M1 as first message. So like
Whereas
this.
that's AM1. Right?
Yes, AM1 is equal to 1. Okay. You don't have to write the hertz because MATLAB will not recognize hertz. Sorry, my mistake. 8 kilohertz is 8,000. This is 10. Sorry, hertz, it will not recognize. 10. Then, what is here? What is here?
Value of signal.
AM2 is what?
Yes, AM2. AM2 is 4 and then
FM2 equal 50.
good. Then, yes, when you will have this kind of data, I think you will be able to write it without seeing it. Yes, for the first message. So I wrote M1 is equal to first message, M2 as second message, so that I can differentiate. So then, so carrier frequency FC. How much? 200. And carrier AC is equals to 1.
AC is amplitude for carrier.
Yes. First, now how I will shift this? Frequency will be the same. Amplitude will be the same for carrier. What will be the difference? What will be the difference?
Yes.
So carrier is here, right?
Yes.
I told you that okay, carrier frequency is 200, carrier amplitude is 1.
Yes.
How I will shift? I will use the same data for both of them.
The amplitude will be the same.
Yes, frequency will be the same as well.
The same.
Then only difference?
Sine, cosine.
Yes. Okay, just write. Carrier 1 C1 is equal to cosine of AC into cosine of 2 pi FC into T. But AC, okay, okay, fine.
We will write AC? No, not AC.
AC equals to 1.
C1 will be.
No. Carrier frequency and amplitude
What's the
will be the
variable?
same. Only AC.
AC it's only amplitude, right?
Yes.
Okay.
Of carrier.
Okay. We will.
Yes. Yes.
I don't put AC. Now I want to write carrier.
Yes.
Okay. We will close.
Okay. Yes. C1
Yeah.
cosine.
I
Yes.
will not write. Okay. Cosine.
No, right.
Oh,
Carry
sorry,
on.
sorry. Frequency.
FC. All right. FC you already
FC.
fine.
Okay. But I can write it. What FC? Touch. Touch it is. Multiply. Right.
Yes.
That's-
And into T.
Yeah.
What is the
Yeah.
cosine of omega naught of T? And also write A amplitude. It is 1, but it's fine. Just write
Okay, what?
AC.
I have to write one? Oh,
AC.
AC. Okay.
This is static. I'm writing so that MATLAB can understand. Static. Yeah. into sine. What is omega now? How you will write omega now? How? Yeah, but yes. Yes. Or if you write omega naught, then here you should write omega naught 2 by 2 by 2 multiplied by 2 steric pi. 2 steric pi steric FC. Carriers.
Also T?
Also messages, both of them, right?
No, T.
Yeah, P, but yes. But I just told her you can write like this, and then you can just use value omega naught here. Yes.
Also by T.
Yes. Yes.
I can see it. لا هذا سي 1 هذا كان الأول يسوي سي 1
Omega naught of C. Okay. Write messages also. Both message M1, M2. M1 and M2, right? How you will write? Just remember this way. This only if you remember this signal, and then write carrier with the shift also. This is first carrier. What is C2? We have two carriers. C2 equals what's yes. C1 AC cosine of omega naught doesn't understand. Not very smart. C2 what? C2 this is C1. Now C2 is what? Yes? Good. Yes, carrier. This is first case, C1. This is C1. Then carrier 2. What is C2? C2. You have two carriers.
Yes.
So define the other carrier with 90 degrees shift.
Also sine.
Sine. Yes, carrier 2 is with sine. See here. Okay.
AC also.
See here, we have two carriers. 1, 2. Remember the block diagram. So this is with sine, this is with cosine. Now we have to write M1 and M2. Write M1 and M2. Zainab, are you writing? Zainab. Okay.
Yes, Miss, I'm with you. I'm trying to write.
Yes. Because why I am doing this practice is so that you understand it for your exam. Okay.
Yes, okay, Miss.
Dana. Dana Hajri. Seven 13. Yes, right message. Why? Same. Same. Cosine of what it will be. Tell me what will be the message, Mahmoud?
Yes.
What is message one? M1.
M1.
Yes. What you will do in the exam? Then you will be looking at me and then I will not come to the class. M1.
AM.
Yes. A.
Cosine.
Which one? M1, AM1.
AM1. Cosine. 2 by F. T.
FM1. Easy. Just remember this equation. Cosine AM or anything. A cosine of omega naught of T is your friend. Okay, for writing any signal. Now, whether this omega is used for XC and then you write omega n1 for message. Otherwise, you do pi into fn1 and fm2. Find fm2. No. You're writing for the message. Yes. No. So message is not signed. It's not the same. Two messages with sign. Only carrier is.
T. 0 lemon. 1 على S. 5 على هذا بالنظام.
Consider you are sitting in exam.
Yes.
Right hand.
Do we have to define the time?
Yes.
So what
Define time after your data.
after
So how you will define time?
T 0 to 1 over Fs
Yes.
2 1
How many cycles? Okay, write 4 cycles.
4 cycles.
4 by FM. FM1. Write FM1 because we have 2 messages.
4 or 4?
This is 4. This one is 4.
Can we define it now?
Yes, you can define it now. You can define in the beginning. You can define it in the middle. But before, when you are using T, define it before that.
Okay.
After FC. Okay, so it means I should give you a difficult question.
F1,
This you will
F1,
be able to write easily, I think. You just have to remember this equation. This is your friend. Just have to use this everything.
FM1 or FM2 under the 4, no.
M1. M1 is fine. 10 no.
Or 2, it's
It's okay. Now where are we?
it's not fun.
Can we plot them? Can why?
It's not fun. Something wrong with the time.
T. Yes. Why? Because define it before.
Define it.
Using T.
Define it after the variables.
Yes, define it before T.
Okay.
Now it will not plot. You have to plot. Plot. See? Okay, let's plot it. Plot message, plot carrier, plot both carriers, both messages. I don't know. Understand? Then 1 divided by Fs. Remember these time scaling and these things. 1 over Fs. Okay. Then 1. And then 4 divided 4 is the number of cycles.
How?
4. I will send this number of cycles. So 4 cycles, 4 divided by 1.
Plot M1, right?
Plot M1, plot M2, plot C1, plot C2.
C1 C2. Plot M2 or C1 C2.
No, not this way. Plot C1, plot M1, M2, C1, C2, 4. All 4. Yes. Here. देखो D.
Oh, what's the deal?
No, first we will put T and 1. T and 2. T, C1, T, C2. Plot. 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 Plot T and 1.
No, G, that one.
Plot T and 2. Plot T, C1, plot T, C2. Yes.
Miss,
Yes.
M2 will be A M1 cosine.
And 2.
A M2
Yes.
cosine.
Yes.
The same.
Not exactly.
FM2.
Done? Okay, okay. Yes. Possible. C1. C. C. That's it. That's more. Okay, done. You didn't define the scale. Zero. Before T. T is already used here. MATLAB is going step one by one, not it's a concept.
Miss,
Control B. Control B. Zero.
Miss,
Yes. What?
what?
How is the signal? Okay, this is good. What happens? One divided by yes, this is good.
Almost there.
And you will not sit during the exam to get this.
Have you been the test?
You will also not sit with them. I know the friends. I will change the friends. Yes.
But more.
Yeah, see this. Just put column. This one. Just put also this two. Yes, everywhere. Yes, yes. See, you can check it. How it is that? This is small movements here. It can you are using FM1 here. Sine is starting from 90 degrees.
Yes.
You will not sit together in the exam. You understand? Your friends. They are at least three friends. Now, okay. Now we are done. Now, what is the next step?
The transmitter.
Yes, channel. Yes. We will pass it through the noise. Yes. One more thing. We have to add it. Now, what we did is M1 and then C1, M2, C2. Here we have to add them. How? So that we get X of T. How we will add? M1 into C1 plus M2 into C2. Like this. Write this. Okay. And name it X. X of T. Name it X of T. X T. Yes. Right. Right. And then the rest you will see what? Yeah. So 10 is for M1. I have to find M1. Cosine is starting from 90 degrees. Yes. So this is starting from 90 degrees. If it is 9, it will start from 0. Starting from 1, maximum point. Okay. I will ask this type of question. I will give waveforms and ask you to find the frequency. Yes. 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 Now next step is passing through the noise, adding noise. Channel is next step, and then in the channel we will add noise. Okay. Remember this block diagram. This will help you. Remember the block diagram which I draw here. That will help you. It's very easy to read from block diagram. So you are done until here.
Yes. Yes.
Now what is the next step? You have X of T. You will add, this is channel. Noise. What was the command for adding noise?
GHD. CMG. Yes. AWG.
Yeah, just name it anything, noise. Only noise, because you only name it anything you want.
And transmitter message.
Channel.
Channel.
Message.
Yeah, transmitter. Transmitter, yes. Transmitter.
I know.
Transmitter message.
There's message carrier, transmit signal channel.
The last one, XT. XT is the addition of, did you add it? M1 into C1 plus M2 into
This
C2.
is the
That
message.
signal,
This
yes,
is message.
that is modulated signal. That is not message.
Transmitter.
Yes, that is modulated message signal.
There's no modulator. There's
It is-
transmitting.
This is modulated. When you multiply carrier with message, it becomes modulated signals. So yes, this
Yeah.
is
And the
plot also this one, plot this also. Plot T xt. You can see that amplitude will be modulated. Xt. Plot it. See.
No.
Why? Why is the message? Yes. Okay. Plot that.
Also,
Why it doesn't? Xt is equal to. Okay. Yes. You have to use this dot operator.
Okay.
Yes, dot. Use dot operator. Data mod is. What's your data is xt SNR. You have to define SNR. In this case, SNR is equal to 20. Signal to noise ratio is equal to 20. SNR, define it SNR equal to 20. Yes, and good.
how we can write this one?
Which one?
Can we carry it?
Which one?
This one, SNR. No, why?
This is modulated. Modulated.
I don't know.
Which is zoom it. Okay, next step. Now, so this is noise. Okay. Noise. I didn't know. Noise. Why? No. Right.
Board carrier.
I will help this.
Okay.
Okay, I did that. So first you need SNR, which is 20. I will give it to the person. Okay. There is modulation amplitude as well as
Okay, how
if you
to
zoom it. Yes, right. Okay. Bye.
how to write the code?
See, now I have until here. Now I have to add this one. For that I need SNR, which is equal to 20.
So we have to
And then name it anything, maybe say
A.
AB,
Okay.
AWGN, additive by proportional. Then here is your XP.
And write what?
And additional additive by proportional. So this is XP, your data. Then SNR. And then here measure. MEASUR. Okay.
Got it?
No, not that.
That's not.
You can check it if you want to check. And what XP. My first message multiplied with carrier. Carrier C1. And down.
Will be the same.
Plus. And 2. And 2. Is it to remove it? I should. Yes. And dot. Yeah, multiply there. Because you don't have so many things.
I think the same.
Yes. What do we say?
There's a bit different. Not because 20% noise I get. Very less noise I get. 20%. I will not tell you. Did I put my pen somewhere? Why we put dot? Why we put dot? Yes. Where is my pen? Did I put my pen here?
No.
So why we put dot? Why we put this? In my first lab, I told you why we put dot.
Not to multiply both.
Okay, I tell you again because these things are very important for your final exams. So this, for example, if you have to, because MATLAB is working as matrix. So if you have a matrix A is equals to 1, 2, 3. If you have B is equals to 2, 3, 4. So if you want this multiplied by this multiplied by this with this, you have to use dot. Otherwise, what it will be doing is, it will just multiply 1 with 2, 1 with 3, 1 with 4. That's it. It will not multiply the other elements. So for point-to-point multiplication, you need dot. Okay? So dot is very important. Noise is the name of the noise. No, but you have to use dot. Dot multiply. Dot multiply. Then right. Okay. Now you are at a receiver. So now what is the next step? You are going to move ahead of me. You are ahead of me. Okay, so what is the next step? Now we are demodulate. Yes. What I will do is I will multiply by this. My now my final signal is y. Okay, now I am here. Okay, so what happens here is C1 is multiplied, C2 is multiplied.
I have to define y and R1 and R2.
Yes. After you say it C1, whatever you want. Say it M1, say it R1. R1, why? Because R is for receiver. R means receiver.
Both transmit signal what?
We already transmitted. This is my Y. Transmitted signal Y. When I transmitted, I added the noise. So this is my transmit. So this Y is my final signal here. What is name of your signal?
80.
Okay, AD is your signal. AD into C1. Your signal is AD.
No, I know, but which category I have to submit? Which one? I added noise.
Only within one, you have only one signal, modulated signal. Here you added, you had only one signal.
There's message. There's added.
Yes.
Transmit.
Yes, this is.
The same.
Yes. This is your transmitted
And
signal.
noise is added noise.
This is added noise. You added noise at with this signal. Signal what is this? XC is this.
This is the added noise.
This is no. This is modulated. Modulated signal is this. You can write the comments so that you remember it. This is
What do I have for that?
here. You have to go see that diagram which I wrote there. Now I am at the receiver. This all is done here at the transmitter. So give me.
Also the channel.
So this is my transmitter. Now this is receiver.
That's it.
Okay, just then. Channel is in the channel guided noise.
Channel one.
It's the channel as channel. Channel guided noise. Then this. You are at receiver now. What you will do at receiver? That step.
This one.
So now your Y is AD.
Yes. R1
Now,
equals AD.
yes. R1 means receiver.
Yes.
Y.
This is a simple signal.
Okay, you didn't add the noise. We are very added noise. Add noise. That first two lines. Okay, so
And receiver I write Y and all this, right?
yes, Y is yes, Y multiplied by carrier here. Y multiplied by carrier 1, Y multiplied by carrier 2. See diagram. I think with the diagram you will understand more. At the end, I will redraw the diagram so that you should know how the diagram is written.
Now what is A and B?
Which A?
A and B.
These are the numerator and denominator of the Butterworth filter. We did this in last, I think, before the last lab. This is numerator. This is the syntax. You cannot change it.
Okay.
This is numerator and denominator of the Butterworth filter. In the Butterworth filter, here you have to tell the order of the filter, and then this is the cutoff frequency which is given in the question.
Okay.
So cutoff frequency equals to 10 microhertz. 10 microhertz is also 1 into 10 to the minus 5. Same thing. This I wrote here.
Okay.
Clear?
And then one.
So then, this is, now this I designed my filter. Then here I am passing my filter, my signal through this filter, R1, this one, because here is my filter. Here, when I will get these signals, then filter, and then here I will get estimated 1, estimated M2.
Okay.
At the end, I will again redraw the block diagram because I understand more from the diagram. So I think you also will be. So here, this is the syntax, you cannot change it. This is the same thing, AB. Okay?
Yes.
Clear? Should I turn on the light?
Yes.
Okay, let me check. Okay, just okay. Now, okay, you are now plotting. So you already plotted message 1, message 2, carrier. You already have these 4 signals. Now plot transmitted signal. XT1 was with signal, without noise. This signal was without noise. Plot this one. Which one was the without noise? Plot T with. I don't know. Your name of the signals was different. Yes. Okay. Yeah. But in the assessment, no, yes. Okay, clear? So don't copy. Don't copy. Just write from your home. Don't copy.
Yes.
Yes. Yes. There will be very little variation because only noise is 20%. 80% is your own signal. Now, what is the next step? That I didn't know. So now just multiply it with C1 and C2. Yeah, your signal is Y. So now R1 receiver is equal to what? Y good. God multiplied by C1. Then R2. Yes. R means receiver.
It's all the transmission, right?
No, this is receiver now. This is channel. Noise is added in the channel. So in the exam, when I will write these things, channel, receiver, then you have to write the code in the actual. Now you are just writing anywhere, but I can use this good. At the receiver. So if I will write receiver, you have to write the code of receiver only in the receiver. And if anything else, then the receiver. Yeah, I will just make one code. Yeah. And then you will split. And you will know. You will know like what is carrier, what is channel. Yes. Because you have to dot. SNR, what is that? What is this? I think after today. Yeah, this is no, no, this is yes, let me check what is the if I take this out. Then from here you see that phase is changing. So how the phase is changing? Amplitude is changes. For example, like this. How the phase is changing? For example, my one wave is stopping here, then other will start like this. Then the other will start like this. This is the change in the phase. Like this. This is the change in the phase. This is the change in amplitude. Okay? This is correct because your last signal is Did you get estimated 1, estimated 2? Yes. Now this you can compare it with your in process. You can compare it with this was your first method, and then this was your second method. After this all the process, it was almost good. So in the exams, if I will write plot signal, then you will write only the plot command. If I write receiver, you will write only the receiver code. Okay?
Okay.
Okay, Heather? But you're still there.
Yes.
Why? Clear? Zainab? Zainab.
Yes, miss, I am with you.
Okay, so did you
You
understand?
want, yes, you want I share screen?
Yes.
Okay, miss, can you see it?
Yes. Go down. Yes. Go down. Yes. Good. Okay. So yes, show me if you
Okay.
write. Yes. Very good. You wrote the code in exact the same blocks. Yes.
Yes.
Then you should know what is modulated. Okay, Zainab.
Okay, miss.
Stop sharing your screen. And I can share. Now, can you help me to draw the block diagram? Complete block diagram, starting from. Can you help me for this? Writing the complete block diagram, and then we will finish. Okay, let's start from here. What is first signal? I am at the transmitter and I am doing quadrature amplitude modulation. Okay. So what is signal here? Here what is this? Yes. Girls also.
Carrier on, carrier.
Yes. So this is how.
Modulated.
No. Sorry. Okay, so this is cosine of omega naught of t, then this is
Sine.
sine of omega naught of t. Then what is the next step? No, don't see there.
Modulated.
Adding them.
Adding.
Then this is my. Then what is here?
Channel.
Channel. What happens in the channel?
Some
Noise.
noise.
Remember the command for noise. Okay, then.
Y of t
Yes.
and demodulated.
Yes. Now. This is multiply. Okay. C1
C2.
and then C2. Then what is here?
Filter.
Yes. Filter. Write these two and then estimated signal 1, estimated message signal. I can ask you to draw the block diagram also. It's easy. This is the most easy thing. If you have this diagram, you can write all the code. Yes?
Yes.
If you have this, because for me it's very easy to write the code using this diagram. Just remember the steps, you will understand this whole modulation thing. Okay?
Yes.
It is the same. This is the step. These are the steps for quadrature, amplitude modulation. This will never change. This will remain the same. Okay. So just remember this. I can maybe ask you for this block diagram also. And then one more thing. So I will also ask you, write the code for receiver. Write the code for channel. Adding noise. I can ask you these. Your final sheet, which I will give you as a, that will be MLX. I will ask you these blocks. Okay? So what is happening in the channel? Remember the block diagram, and then nothing will be difficult for you. Okay? Done? So I want to ask your attendance. Yes, close it. Did you understand today well or not?
We understand.
Saud, Mahmoud, Haider, and girls. I don't know the name. Fatima. Ritaj, okay. And okay. IB. Okay. Which section is this? Okay. So done. Is it clear? Okay. So online students, do you have any question? Any questions?
No, miss, it's okay.
Okay. So I will stop sharing. So this is over. Class is over. So next lab is the final lab. After that, you can do revision yourself, and then I take exam after 1 week.
Yeah, marvelous.
Okay, good.
Okay.
Are you ready? After 1 week for the exam.
لا طب هو فيديو هتزود فيديو.
What you will do in revision? You want revision?
Yes.
Okay, then after the next week revision, then exam.
Yes.
No, I didn't cancel any lab. Why? 4 labs are like this same.
Yeah, I know, it's too much. 9 labs. It's 9.